Front-running and back-running attacks are easily one of the most common attack vectors that apply to smart contract systems. Understanding exactly how these attacks work and understanding how they can be applied to any code base will immediately boost the amount of bugs and vulnerabilities that you're able to uncover. So exactly for that reason, today we're going to cover everything there is to know about front-running attacks. And then we're going to have a look at a few front-running related findings, and we're going to see a framework that you can use to uncover these vulnerabilities more often. All right, and of course, before we begin, my name is Owen, and over a year and a half ago, I co-founded Guardian Audits, and ever since then, we've audited hundreds and hundreds of smart contracts and uncovered dozens and dozens and dozens of critical and high vulnerabilities along the way. And my goal with every video that I put out is to distill down everything that I've learned along the way and give it to you so that you can ultimately become a much better blockchain developer, security researcher, whatever it is you're looking to be in a fraction of the time. All right, so without further ado, let's get into these front-running attacks. All right, we're going to start off by getting first a high-level understanding of the exact functionality that enables these front-running attacks, and then we're going to go and we're going to see how they can apply to code bases and see the different types of front-running attacks that can come up. So first of all, we're going to dive into the whiteboard here, and the very first thing we need to talk about here is the mempool. So let's imagine the mempool as literally a pool of just transactions. So let's say we have all these different circles here, and each circle here is a transaction. So we have a pool here. This is our mempool. Let me just write it out. So we've got our mempool here, and it has a few transactions sitting in it. So when I send a transaction to the network, it is basically going to, before it gets actually picked up and recorded into a block and finalized on the blockchain, and we know my transaction has been recorded, the state is final, it is going to be sent to sit in this mempool. And so this mempool is sort of just the aggregation of all of these transactions that are waiting to be recorded in a block, right? So when they do get recorded into a block, we're going to have all of these transactions that are sitting here. They're going to get formalized. A subset of them will be formalized into a block that then gets recorded, and they're going to get put into a block in a certain order, right? So let's say if this is transaction 1, this is transaction 2, this is, or let's make it even removed from numberings. If this is transaction A, this is transaction B, and this is transaction C. These three transactions could happen to get ordered in a block, like B could be the first transaction in a block, and then A can be the next transaction in a block, and C can be the final transaction in a block, if we have a block that only has 3 transactions in it. And so you could also have a different block ordering where you could have A, B, and then C. And you have all these different permutations of orderings of transactions within a block. And so if each of these transactions, if transaction B, transaction A, and transaction C interact with completely different systems, and they don't even overlap and affect the execution of each other, they're completely disjoint, then the ordering is, arbitrary, right? So maybe this one is going on Uniswap and it's buying like some ether with some DAI. Perhaps this one is opening maybe you're opening a position on Aave, you're borrowing some DAI or something like this. And then maybe on this one, it is, let's say, doing like a reward auto compound for an optimizer vol, a urn vol, or something like this. So all of these things are completely unrelated. That would be fine. It doesn't matter what the ordering is. However, if see both of these systems, both of these transactions here, let's say B and A interacted with the same exact smart contract system, then there might be a difference depending on if B comes first and A follows, or if A comes first and then B follows. There might be literally a difference in the outcome depending on the ordering of those transactions. And so at the most abstract level, what a front-running attack is, and it could even be considered like a back-running attack, which we'll see and we'll get into in a second, is just manipulating this ordering of transactions in order to be able to either grief one user, cause them to have some loss, or cause them to have their transaction revert, or something like this. Just change the execution of their original transaction in a way that is not ideal for them. Or you can get a better outcome for yourself in some cases, where if I was to get my transaction recorded before somebody else's, it can benefit me. So that raises the question, how exactly can I get my transaction to be recorded before somebody else's, right? How do I get this A to be recorded before B in this sort of like scenario 2? If this is scenario 1 and I'm the person who sent transaction A, how do I get scenario 2 to happen, right? Well, so to understand exactly how we're able to do this, we have to sort of dive in and look a little bit closer at how the gas pricing and the incentivization for the nodes that are actually including this block works. So at a high level, the most important thing to know is just that I can increase the amount that I'm willing to spend on gas in order to get included higher up in the block. And so the way that our like gas calculations break down is, for each transaction, we're going to have a base fee, and then there's going to be a priority fee on top of that. And the priority fee is what's actually going to go to the validator and is going to be able to get adjusted to be able to get our transaction recorded higher in the block. And so we can see, if we go to the Etherscan gas tracker here, we can see that we have some gas estimation here, and you can see the base is 37 GWh, this is gigaway, and the base is the same for all of these estimated transaction speeds. So if I want my transaction to be recorded faster, or even recorded just higher up within an individual block, then we can increase the priority fee here. And we could basically see, for example, for Uniswap, V3 swap, which they're estimating, would expend around 180,000 gas. We can take our 40 GWh and we can convert our 40 GWh to this much way. And then if we go ahead and do the computation of that 40 GWh times our 180,000 gas, then that's going to give us some E15 number. If we go ahead and divide that by 1E18, that's the number of actual ether that we're going to have to pay for this transaction. So as we increase this 40 GWh number, this gas price, which is the net of the base fee plus the priority fee, if we increase that, we're going to be paying more, and so we're going to get recorded earlier on. And so this, if ether is worth $2,000, I'm not sure what it's at right now, I don't check price, then this would be $14, and I think so ether must be doing a little bit worse right now, so it's actually around $8 or $9 here. So of course, all I've got to do, I've got to up this priority fee, and then I can ensure that my transaction A can get recorded before the transaction B, because I can basically come and I can observe, okay, what is the priority? What is the priority fee of B? What is the base plus priority fee? How do I just beat that? And then as long as I beat that, then I can get recorded in the block before. So with all of this said, it is just important to note that on some networks like Arbitrum, which is a layer 2 and it has a sequencer, front running like this is not actually possible because there is no public mempool as the sequencer basically takes these transactions, you submit the transactions to the sequencer, and the sequencer will do its own ordering on a first come first serve basis, and there's no public mempool to be able to observe and check somebody's gas price and then one up them and get ordered before them based on that. The sequencer is basically doing a first come first serve ordering, and there's no mempool to check, so there is no real front running that can happen on a network like Arbitrum that has a sequencer. But on L1 mainnet ETH, of course, this is a very, very real thing, and it happens way more than you can imagine. Okay, so let's see how this concept can actually be used and applied to real smart contract systems, and what are the types of findings that you can actually uncover with this sort of attack vector. So I've got this finding stake 1 pulled up here, and this is from a system where users basically are holding a token that receives value from these like individual transactions that add value to the token. So before we read the finding, we can sort of just map out what the system looks like at a high level. Is basically, you can imagine it as there's one pool of value, and then users can basically stake their tokens to get a share of that value, and they can unstake to basically like collect their rewards and then unstake, get out of that pool of value. And so while you're staked in the system, you will get whatever value delta happens while over the course of your stake. What does that mean, right? If I stake when this has, let's say, to keep it simple, let's say I'm the first staker and I come in, I stake, and originally it's worth $0 in here, right? So let's say I'm the very first staker and there's no staking rewards that are to be distributed to the stakers. Then a few days pass, a few days go by, and now there is $100 in here. And so now what I can do is I can basically like claim my rewards. I'm the only staker, so this $100 just goes to me. Now, the important piece here is looking at how exactly the $100 accrued here. It's not a like second by second accrual of like, 1 cent per second or anything like this. It is a single transaction that will bring $100 of value, add $100 value to this pool. So if we were to graph out the value of this staking pool over time, if this is basically the money that's sitting in the pool, and then of course this is time, it does not look something like this. It looks actually something like this. We're at 0, we're at 0, we're at 0, we're at 0, and then all of a sudden at time 2, there's a transaction that auto adds $100. So say this is $100 value. There's a single transaction that in a single block adds $100 to the value. And so when we see a stepwise jump like this is a prime candidate for being able to come and front run, stake literally right before. You could even go in the same exact block and just get before this, and then I can unstake right after, and I'll still get the same rewards as if somebody had been, they've been an OG, they've been staking since t equals 0. And they continue to stake forever. I get the same exact rewards just by being somebody who came in, saw that there's a transaction to add $100 of value, get in there literally right before it, and then I can claim that $100 of value immediately and just unstake right after. And so exactly what this would look like in this front-running scenario is if this is the transaction to add $100, so if this is the plus $100 transaction, and let's say A was my transaction to stake, I'm doing this like I'm the malicious front runner here. This is my staking transaction. Now, instead of this situation happening where $100 gets added first and then I stake, in which case I don't get to claim any piece of that $100. I want to reverse it. I want to get A before B. And so we stake first, and then immediately afterward, literally in the same block, they add $100 to the value. And then I'm immediately able to withdraw some of that, and I can unstake my stake. And so I never really had to stake for any real amount of time to be able to reap the rewards of that $100. And the $100, it really belongs to the people who have been staking for this entire period, right? And so if we read the finding here, it says there exists no fee or lockup period associated with staking to receive a portion of the rewards compounded during the really long name function. A malicious actor may simply buy GMX key and stake right before the really long name function to immediately accrue a portion of the collected rewards that were meant to be attributed to other stakers. The malicious actor can then immediately claim these rewards, unstake, and sell GMX key after the reward compound, therefore stealing rewards from other stakers. And so this is exactly what we've described here. Is there's literally there's no disincentive to be able to not do this, right? When I stake, there's literally no fee for staking, there's no fee for claiming, there's no fee for unstaking, there's no lockup period or anything like that. And so these stepwise jumps here can be essentially just the value can be fully extracted out of them that way. Okay, now we have a second front-running related finding. This is a good medium finding. And the description is basically because order ID is a value chosen by the user, a bad actor can basically grief them by front-running the user's transaction with their own transaction and using the same order ID. And this will cause the user's transaction to revert, and it could be particularly detrimental if the user had a time-sensitive order and they really needed to increase their collateral to avoid liquidation or something like this. And so if we actually look at the code here, basically the issue is just that if we call this create order function as a normal user, we're providing an order ID, right? And then that order ID will go on to be used in the construction of our order and later the execution of our order. But of course, if an order exists with that same order ID, then my order cannot be created. We can't like overwrite an order that has an existing order ID. That would be a much worse issue. But essentially what can happen here is in the mempool, I can observe somebody's transaction B, and I could see that they're using an order ID of 7. And I see they're using an order ID of 7. It's an important transaction for them. They need to increase their collateral amount or else they're going to get liquidated. Maybe I stand to benefit from them getting liquidated. And so I can observe all of their transaction data sitting there in the mempool, and I could say, well, why don't I submit a transaction A, that uses the same order ID of 7, and then we just need to have my transaction A get before their transaction B. And so I just up the gas priority fee, and then my transaction A gets recorded before theirs, and then ultimately mine will create the order ID, the order with the order ID of 7. They will then attempt to create an order with an ID of 7, and it will revert because of course my order already exists with an order ID of 7. And so they're not able to increase their collateral, and potentially they get liquidated because of that. And so the recommendation is, of course, to use some sort of a monotonically increasing nonce, or perhaps make the order ID a hash that includes the message.sender, so it's unique to the message sender. It can't just be something that you just observe and then copy. It's something that actually depends on who the message.sender is at the time of when you're constructing that order ID. And so this is a fantastic front-running attack by the OX Lanterns team in one of our Guardian Defender audit contests. Okay, so those are two great examples of different kinds of front-running attacks. You can see how front-running is really a class of attacks, and it can apply extremely differently depending on the use case, depending on the system, depending on what the attacker is even trying to achieve. And so let's talk a bit about how you can uncover these types of exploits and what are the systems and the frameworks that you can use to uncover these exact same things in your own security reviews. So first of all, we need to be checking for stepwise changes in the balance of things that are shared. So often in basically almost any DeFi protocol, there's some sort of shared pool, right? And this is sort of just by way of the design of Solidity and the design of Ethereum, it just makes sense to have a shared pool. You have a vault or something like this, and it just accrues value over time. Well, we accrue value to the vault, and then everybody just owns a piece of the vault, right? So we need to pay very close attention whenever there is a single transaction that adds value to something that is shared in a single instant, right? So we need to be paying attention to any kind of stepwise jump in the value of things like this. So that could be a stepwise jump in the worth of a token, the stepwise jump in the amount of assets that are sitting in a vault, or anything like this. And so whenever you're in a security review and you're looking at a protocol that has some sort of reward distribution mechanism, then pay very close attention to stepwise jumps. They can often be sort of sandwichable, where somebody deposits and then withdraws right after. Another kind of front-running attack, which is related to the kind of front-running attack we saw from the OX Lanterns team, is the kind where we change a specific variable, we change a piece of state right before another user's transaction, and that affects how their transaction is executed. It might affect the price that they get executed with. It might affect whether that transaction reverts or not. But in the end, it just causes a negative outcome for that user and or a positive outcome for the malicious actor. So when you're walking through the fundamental goals of a system, ask yourself, what variables could impact the execution of this transaction? So whether it's a user executing something, like they're creating an order, creating a position, or even doing a swap or anything like this, ask yourself, what variables can affect this? Great, now that we have a list of those variables, now how could somebody potentially front run to change those variables and negatively impact the user? And then also, if it's maybe a keeper or an admin making changes, you can also ask yourself the same question. What are the variables that would affect this? Or how would a user even benefit from this change happening if I sort of like front ran the owner's manipulation of a value and then back ran it to maybe be able to arbitrage the difference in a select parameter that they're setting for the protocol or something like this. So at a high level, when you're analyzing these select external calls that users or keepers can interact with, think to yourself, what variables can manipulate or benefit off of this action if I were to front run it or back run it or both? All right, so that is everything you need to get up to speed on front running and exactly what these types of attacks actually look like in real code bases, and even a framework that you can use to uncover some of these vulnerabilities yourself. Now, in the next video, we're going to build off of this one. We're going to understand the infamous sandwich attack. We're going to see how these front-running attacks and these back-running attacks, which we didn't really talk about too much, can be combined to basically extract more value from people who are swapping on an AMM. So I hope you got value out of this video, and I hope you're looking forward to that one. And of course, if you're on a team that is building a cool, new, innovative DeFi protocol, and you're looking for a smart contract audit, you're starting to think about security reviews, then I want to know about your protocol. And I want to know about it so much that when you go to guardianaudit.com/quote, I'll even do a completely free initial pass, get any initial security notes, things that ought to get fixed before going into a smart contract audit, any initial glaring vulnerabilities or informational findings when you submit an application at guardianaudit.com/quote. quote. And of course, if you happen to know anybody who is looking for a security review, they're starting to go through that process, then of course send them to guardianaudits.com/quote. And last but certainly not least, if you're really interested in this Web3 security stuff and you want to double down and you want to really up your game and connect with people from across the world who are also interested in Web3 security, and you might even be interested in joining and teaming up with others and competing in real audits of real protocols and even getting rewarded for your findings, go ahead and apply to join our free community of security researchers at lab.guardianaudits.com. All right, that is all for this time. I cannot wait to see you in the next one.